तो हेलो गाइस, वेलकम बैक टू माय चैनल। सो गाइस, आज हम डिस्कस करने वाले हैं कुछ एसिड बेस एंड सॉल्ट के प्रीवियस ईयर क्वेश्चन। सो देखते हैं कि फर्स्ट क्वेश्चन क्या है। क्वेश्चन फर्स्ट है, आ स्टूडेंट ड्रॉप्ड अ फ्यू पीसेस ऑफ मार्बल इन डाइल्यूट HCl contained in a test tube and the evolved gas was then passed for a long time through lime water. ओके, सो पहले तो हम देखेंगे कि जो यहाँ पे गैस इवॉल्व हो रही है बेसिकली वो कौन सी गैस इवॉल्व हुई यहाँ पर। So in this test tube, we have hydrochloric acid, HCl, and some pieces of marble. Okay. And from marble, we know that calcium carbonate is present. Okay. For example, in chalk powder, calcium carbonate is present. Similarly, in marble, the component present is calcium carbonate. Okay. So now these two are reacting with each other. This is dilute HCl. Okay. So calcium carbonate reacts with dilute HCl and a gas is evolved. Okay. So we'll see a reaction first. Calcium carbonate is reacting with dilute HCl. So we know that here we have +2 charge and here the charge is -2, +1 and -1 charge. So this calcium combines with chloride, so we'll get calcium chloride. Okay, calcium chloride is formed. Along with, we know that H2CO3 is also formed, and we can also write H2CO3, 2 CO2 and water. So this is nothing but H2CO3. So when H2CO3 breaks, we can write it as CO2 and water. Okay. So now we have a gas evolved. So this CO2 gas is evolved. This CO2 gas is evolved. Okay, or you can say this gas is liberated from the reaction. Okay, so this CO2 gas is liberated from this reaction and it was then passed for a long time through lime water. So lime water is calcium hydroxide. Okay, aqueous calcium hydroxide. This is lime water. So this gas is passed through this calcium hydroxide solution. Okay, so if we pass gas through lime water, or you can say calcium hydroxide solution, so the product formed will be calcium carbonate as well as water. Calcium carbonate and water. And this calcium carbonate, which is formed in this reaction, is insoluble. Okay, this calcium carbonate is insoluble and a milky color is obtained. You can say a pure milky color is obtained, and along with some precipitate of calcium carbonate is also formed because it is insoluble in water. Calcium carbonate, okay, it is insoluble in water. So this is the case when we pass CO2 gas for a very short time. Okay, so for a very short time, if we pass CO2 gas through calcium hydroxide solution, then the product form will be calcium carbonate and water. But in the present question, we passed this gas for a very long time through lime water. So first of all, this reaction will occur. Okay, this is the step 1. This is step 2. And if we continuously passing CO2 gas, then at step 2, this is formed. Now this calcium carbonate reacts with CO2 gas, because we are continuously passing this gas. So we have excess CO2. ठीक है, excess CO2 gas is passed through lime water. Okay, through lime water. So excess CO2 is passed through lime water. So what will happen now? So first of all, calcium carbonate will form. Okay, and the solution turns milky. But on continuously passing this gas, so the product formed will be calcium hydrogen carbonate, or you can say calcium bicarbonate. Okay, calcium hydrogen carbonate. This will form. Okay, because we pass excess CO2 gas through lime water. So first of all, the solution turns milky, and later on, if we continuously passing this gas, then a colorless solution will be obtained. A colorless solution will be obtained, and the milky color, you can say, disappears from the solution. Okay, milky color disappears and a colorless solution is obtained. Colorless solution formed. Okay, and this colorless solution, now see, here we have calcium carbonate, which is insoluble in water, and that's why a milky color is appeared and a precipitate is formed. But in this case, a colorless solution is obtained because this calcium hydrogen carbonate is soluble in water. Okay, it is soluble in water, and that's why the milky color disappears from the solution. So our question is, what changes would be observed in lime water? So what changes? So you can see, first of all, what changes would be observed in lime water? So this lime water, first of all, turns milky. Okay, and on passing excess CO2, this milky color disappears and a colorless solution is obtained because of the formation of calcium hydrogen carbonate, which is soluble in water. So write balanced equation for both the changes observed. So you can see this is step 1, step 2, and this is step 3. So this is all about the question that what changes would be observed. So here you can write that the milky color disappears due to the formation of calcium hydrogen carbonate, which is soluble. So this is all about question number 1. So let's move on to question number 2. So in this question, we have 3 parts, A, B, and C. So let's discuss one by one. So in part A, we have write the formula and chemical name of the bleaching powder. So now what is bleaching powder? So the formula of bleaching powder is CaOCl2. Okay. And its name is, chemical name is calcium. Here we have calcium and here we have oxygen. So for oxygen, we use oxy only. Okay. Oxy, and we have Cl2. So we'll write chloride. So this is the chemical name, calcium oxychloride. Okay. So bleaching powder is known as calcium chloride. So this is the formula, chemical formula, and this is the calcium oxychloride. So this is all about part A. So now in the part B, we have write the chemical equation to represent the action of atmospheric CO2 gas on bleaching powder when exposed in the open. So okay. So we have to represent a equation where atmospheric CO2 gas is reacting with bleaching powder when exposed in the open. So for example, we have this calcium oxychloride, okay, and we have this atmospheric CO2. Okay, so bleaching powder basically has a tendency to decompose when it comes in contact with CO2 gas. Okay, atmospheric CO2 which is present in the air, atmospheric CO2 which is present in the air. So the decomposition of this bleaching powder will take place. So on decomposition, we will get products, calcium carbonate as well as CO2. So you can see this reaction is balanced or not. So here we have one calcium, two chloride, one carbon. Okay. So this reaction, I guess it's balanced. Yes, this reaction is balanced. And now you can see that it releases chlorine gas as well as calcium carbonate is formed. Okay. And we know that this chlorine gas, which is released in the step, or you can say in the part B, in this reaction, basically, it loses its activity as a bleaching agent. Okay. अभी हम बात कर रहे थे कि ये जो है कि ब्लीचिंग पाउडर है, ठीक है. सो ये जो ब्लीचिंग पाउडर है ये काफी सारी इंडस्ट्रीज में यूज होता है, लेकिन जैसे ही इसको हम ओपन में रखेंगे, सो जब ये CO2 के कांटेक्ट में आएगा, सो बेसिकली यहाँ से क्लोरीन गैस जो है बाहर निकल जाएगी और ये जो कैल्शियम कार्बोनेट हमारा फॉर्म होगा. तो यहाँ पर ये जो हमारे प्रोडक्ट्स बन रहे हैं इस रिएक्शन के, अब ये एज अ ब्लीचिंग एजेंट हम इसको नहीं यूज कर सकते. ठीक है. दीज प्रोडक्ट लूजेस इट्स एक्टिविटी एज अ ब्लीचिंग एजेंट. सो यहाँ पर अब ये ब्लीचिंग एजेंट की तरह जो है नहीं हम इसको एज अ यूज कर सकते, बिकॉज इट इज एक्सपोज टू एयर. सो इन द पार्ट सी we have, why is bleaching powder used in water treatment plants? So basically, you know that when it comes in the contact with atmospheric carbon dioxide, so it releases this gas. Okay, this this chlorine gas which is released from here, it kills bacteria. Okay, it kills Cl2 gas, kills bacteria present in water, and makes it safe for drinking purposes, So this is the reaction involved, and when these products are formed, so chlorine gas is also liberated from here, and this gas kills bacteria present in the water and makes it safe for drinking purposes. So that's why bleaching powder is used in water treatment plants. Okay, so this is all about the today's question. So thank you so much for watching.